own moniker. The incentive for this really was I kind of felt that there wasn't enough discussion around JavaScript obfuscation, and the obfuscation samples that I was seeing in the wild that were being used were a little lame, could have been improved. So basically I'm going to go over oh hey, I have a microphone. And I apologize for the interruptions for anyone who's watching a recording. Is this live streaming or no? Cool, that's better. Makes me feel better. All right, quick overview. I'm just going to be doing an initial introduction, give you some background, set up a test environment, set up the constraints for the test environment, and then rip apart a live sample of malicious JavaScript. Go over some additional notes where I think they did well, where I don't think they did well, where they could have done better, and leave out with some closing thoughts on that. The purpose for this the purpose for this presentation really was just to kind of share knowledge. Again, I kind of felt like I was talking by myself a lot about JavaScript obfuscation whenever I was going to local OWASP meetups or even to AHA. I know that there are some individuals who are quite well versed in it. Egypt, for example, who contributes over to the Metasploit project, is pretty well versed in JavaScript obfuscation. But I just didn't feel like a lot of people were playing around with it enough, and it's so easy. It just seems like something that should be pushed. So why I think JavaScript obfuscation deserves a little more attention really revolves around some of the trends that I've been seeing since I've been working in the security industry, obviously. As you start going to more and more applications, you're going to start seeing that a lot of the feature sets are pretty much entirely delivered through JavaScript. And the result of that type of behavior is that more and more user-supplied information is being processed through JavaScript. This introduces all sorts of interesting conditions, but mostly it's just changing the dynamic of injection attacks. A lot of the injection attacks that you're going to start seeing are going to be reflected back within JavaScript space, changes the meta characters that you need, kind of trips everything up from what people have been mostly focused on, which is HTML-based or attribute-based injection. JavaScript-heavy applications that you've seen exploits for, Facebook, Blogger, Twitter, and the usage percentages are pretty crazy. I had no idea that jQuery is on over 50% of the top 10,000 traversed sites. Over 50% are using jQuery. And jQuery in and of itself, without any malicious content appended to it, is a sink. You can actually hit the jQuery file directly and actually get it to document.writeout to the DOM. That was something that was proven by Stefano De Paolo out of Italy a while ago. I think his organization is called Minded Security. Check it out if you don't know it. But as I said, JavaScript handles more and more user-supplied content than ever before, and as such, you're going to start seeing a lot more injection attacks in that space. So you should probably know how to obfuscate your content so you can bypass really stupid filters that developers are going to start putting up to try and prevent injection attacks. As I said, common validation solutions don't really address this problem. A lot of the ASP.NET native solutions, validate requests, for example, or PHP's magic quotes, or any other MVC data validation library that's out there, spends a lot of time focusing on, specifically on string encapsulation. So escaping any form of double quote, single quotes, and then also literal declarations for those characters. So that's pretty much all they really focus on. And WAFs are just as what's the word I'm looking for? If I only had a brain. Wow, I totally spaced on that. But they're also culpable for that. The good news is that people have been actually working on it. AV vendors decided finally that that there is no point in trying to design some form of string-based matching system against a fully Turing-capable language. Kind of seems like a losing battle. So they started triggering off of the actual events from the JavaScript execution stack itself, and using that as an exception condition to trigger if it sees any form of write-outs to the DOM or modifications of the DOM to what it considers a domain that's not on an accepted whitelist, which is a lot easier solution, right? But even now, because of this kind of mashup environment that we're in, and due to the way the kind of lagging behind same origin policies, often these end up getting turned off because they just create a huge amount of noise. It's false positive ratios are skyrocketing. So most people don't even pay attention to the fact that their AV says, oh, by the way, JavaScript's doing some weird stuff. And so we're back to square one. There's one guy, however, who is incredibly stubborn. His name's Gareth Hayes, I believe, out of the UK. He has a website called thespanner.co.uk. He himself is a security services provider, and he has been heading up a project called JSReg, which is essentially a heuristics regex library to directly take on JavaScript obfuscation and trying to address it through string-based matching, which to me seems insane, but he's done a pretty good job at it. That is a bar, which is better than no bar. So obfuscation, most of you guys, I'm assuming, have already had experience with obfuscation. You already know what it is. And in most cases, a lot of people that, for me, for example, I treat it as a hobby. It's a puzzle. It's for fun, right? Identifying new and unique conditions in which you are able to execute the exact same behavior you could write in, 5 characters is kind of fun. And the benefits are kind of obvious. You have the ability to disguise content. That's great. Everybody knows that. But you can also set up traps, which is, to me, a little more entertaining. Trying to trip up individuals who are ever trying to conduct analysis against your JavaScript. And you can do this through a number of ways. You could have remote source-ins so that there's a concept of packing and unpacking, right? If you have highly dense JavaScript or obfuscated JavaScript, and what those packers or unpackers can do is change content that would in and of itself be syntactically invalid. So if someone got one portion of your multi-step JavaScript obfuscation payload, that portion could be syntactically invalid. If they ever tried to actually interpret what that did, they'd spend hours trying to figure out something that honestly wasn't even there. It's just ghosts in the machine. What ends up happening is the packer, or the unpacker, I should say, that's already delivered in step 1, manipulates that JavaScript on the fly, making it syntax correcting all the syntax issues, and then rendering it, executing it. And there are a ton of other tricks that you can do with this. Just doing Boolean triggers to identify conditions where they're using any form of an automated analysis engine, like if you're being rendered in Rhino, a Rhino execution environment instead of actually a browser, you can fundamentally change the behavior just with one Boolean trigger, right? That's not necessarily going to stop them from figuring out what the other script did, but it is going to prevent automated honeypots from figuring out what your content was doing if all they're doing is triggering off of the execution events, right? And then finally, compression. And I do have an asterisk next to that because that's give or take. Sometimes you get benefits. There's a very perfect condition where your packer or unpacker will be able to take some content and make it smaller than it actually was, and you gain a bunch of performance gains from that. You can also simplify the execution process, but that doesn't always correlate with obfuscation. Sometimes it doesn't actually make it any more difficult to interpret what the content is doing. So that's 50-50. Sometimes you get compression. Most of the time you don't, right? If you want to do the really fun stuff, it's going to be like 50-to-1 type ratios. So setting up a test environment, you want to go through the process of conducting some analysis against JavaScript. What do you need? Personally, I prefer just running through a browser. There are programmatic analysis approaches where you can use deobfuscation libraries or deobfuscation scripts. JS Unpack is probably the most well-known for that, and a lot of people automate their honeypots and automate just JavaScript deobfuscation in general with that library. If you don't feel so comfortable with standing up your own environment and manually walking through an execution path, you can use Malzilla. That project hasn't been supported since 2008, so go at it at your own risk, but at least everything is self-contained within a single interface. You're able to walk the HTTP request responses in conditions where it's a multi-step execution flow. So you can, that's really the benefit that you get from having a browser instead of doing programmatic analysis. You don't have to write an entire HTTP stack to handle all the callouts to additional content and then maintain context across all of those deobfuscated scripts, right? Because programmatically, that's a pain in the ass. But if you're doing it manually, pretty easy. The only problem is manually you can't do it in mass. But for this case, for the examples, we have Firefox 3.6.23, I think that's right. 3.6 is my favorite. I know there's like 14 billion versions of Firefox now, and frankly, I don't care enough about HTML5 to start using it as my main browser. That doesn't mean I don't have it installed and testing in it, but I prefer to stay on the stable workhorse. Plugins, these versions correlate with the version of Firefox that I'm running. There are newer versions of these plugins, but they only apply to newer versions of Firefox. But Web Developer Toolbar, Firebug, User Agent Switcher, and then I wrap everything under Sandboxy. And Sandboxy is beneficial if you ever actually intend on pulling down the actual malicious content and you don't want it to just execute on the fly, and if it happens to actually target your Firefox environment, might not be so good. And that's just one layer of protection, right? If you're messing with malware, you know, normally they say don't double wrap. This time you definitely want to. Hardware, run it on anything. Anything that can support the software, that's all that really matters. Personally, I run everything off VMs, and those are disposable. You can template them, and then you just revert every time you go through a new sample. So the constraints for what this particular sample that I'm going to walk through, the constraints for this is I did most of my testing all within Firefox and IE8. And again, all the results, valid JavaScript, all render under both those environments. And again, I'm focusing on JavaScript, and it's flexible, it's everywhere. That's why JavaScript obfuscation is awesome, and pretty much everything else is kind of lame. Example analysis. So this piece of malware I came across on a WordPress install. It could have gotten there through an automated script that came by and did an auto exploit and changed a file. It could have gotten there manually. I don't know. All I know is that this jQuery file definitely was not a normal jQuery file. It had all the characteristics of 1.4.2, except it had a huge block of appended JavaScript at the end of it. And prior to executing that huge block of appended JavaScript, it unset all of the variables for jQuery first, which was the one thing that made me go, huh? Wait a minute, that's what tipped me off. It's a two-stage deployment mechanism. First one is just, it's a really long, obfuscated process to check whether or not your user agent header has IE in it. Seriously, that's just crazy waste of space, but okay. And then the second stage is just payload deployment, which really is just a huge hash with a bunch of unique IDs going and hitting some remote server, and they're using DHTML to pump down each new payload into your DOM, so the victim browser is constantly fetching each new payload. None of the AV vendors caught this, and as I said before, only a few AVs right now are really triggering off the execution events. Most of them are still doing just straight up string checks, mostly with regards to the DOM. They don't even really check JavaScript anymore. They mostly just check whether or not the request out hits some blacklisted domain against some list that they get through some service that they pay for, right? And that's what most of the AVs do, because most of the AVs don't have the budget or the team to be able to do authentic research. The only three that caught it were Avast and GData. I guess Avast 5 is just another version of Avast, huh? Maybe it's just 2. Bad stats. Anyway, less than 10% caught that this was actually a malicious piece of content. And again, it could have been deployed through a worm. It could have been deployed through any number of, I mean, it's WordPress, right? So I think that's kind of interesting that only 3 would actually catch it out of the 44 that were tested. This is the first section of the JavaScript. And the funny part is this is the easy one. This is really, really simple. All it does, it's just a giant array of octal encoded strings. Very, very simple. The variable declaration, if you notice, has the underscore in front of it. That's actually a valid character for variable declarations. Invalid characters would be like numbers or any of the other reserved meta character space, percentage, percents, exclamation points, question marks, that type of stuff. Octal strings, all wrapped within an array. There's a null entry in there. Don't worry about that guy. And then the array is all assigned to one variable, and everything's fine. It moves on. I just do a quick index of this. This is the deobfuscated content, or the de-encoded content, I should say. The only 2 indexes of this array that matter are, did I skip a slide? We're going to go forward and then back. The only two indexes of this array that matter are the first and the fourth, sorry, indexes. The first one is actually the evaluated content. That is the JavaScript that'll run, but it's all compressed. It's just a bunch of representative values. None of it's been populated yet. The fourth one is just a giant hash, and eventually what happens is the unpacker goes and just does a split off that and creates an array out of it, right? And the delineator is pretty clear. It's a pipe. One of the things that I would note that they could have done better, and which I kind of surprised that none of the AVs caught this, because if the AVs were doing just basic, all they had to do was just unencode the octal representation, right? An octal is pretty obvious. You see it /x, 2 characters /x, 2 digits /x. But they didn't. But what they do have is pretty heavy, what I call weighted keywords, document, element. These are the types of things that are going to trigger really, really rudimentary malicious JavaScript like filters. It would have been just as easier to create the first entry of that array to be doc and the second entry of that array to be umint, and it would have bypassed any risk of any of those catching it. So I think that that could have been improved. But otherwise, you know, I guess octal is good enough for now. One of the other things that I wanted to mention, if we go back, so again, they use octal encoding. But that's the only encoding type that they use. And the beauty about JavaScript, especially when you use string encapsulation, is you can mix and match any encoding you want, and it still interprets it all to ASCII, all at once. So they could have mixed it with a variable amount of encoding types. They could have used Unicode, octal, or sorry, octal is what they were using, and hex. Decimal is a little different. Decimal, you have to pass it through some methods before you can actually get the raw string out of it. But Unicode, octal, and hex can be mashed together all in one string, and JavaScript's native execution environment will be like, oh, I know what that is in ASCII, and you're good to go. So, and again, what we care about here is to prevent any key strings to be referenced. So if you have a obfuscation script that you're running, you want to be able to iterate over these different encoding types as you're generating a single string. Not just every entry within the hash or the array, but every string itself, each character, you're iterating over those 3 optional encoding types, right? So it's just a mess. It doesn't even look right. But it works because JavaScript's awesome. So here's some custom payloads I wrote myself, just to kind of represent some of the things they could have done better. So the reason why they used the underscore is pretty obvious. They basically didn't want to have alpha at all as the lead of the variable, because almost every single rudimentary unpacker says variable starts at either var space or letter equals. So they're just bypassing that regex check. But you can obfuscate it even further, because a lot of those checks occur before the interpretation of the encoded value, and you can use Unicode directly in a variable declaration. So you can mix and match ASCII and Unicode as well as the underscore as the leader, and just completely fuck everything up, because they're definitely, if they're not checking for underscore, they're definitely not checking for slash. One of the things that, and again, as I said before, you can use packers and unpackers to modify a variable declaration. So you could have a syntactically incorrect variable like numeric value, and then modify that on the fly later on. So even though initially it looks very compressed, but it's syntactically incorrect, your unpacker ends up modifying that to something else that's more accessible. Reduces the overall message size, and like I said, doubles as a trap, because if they ever just get that intermediary layer, they're not going to know how to execute it because it's syntactically incorrect. What else did I do here? Oh, references to window. Most of you guys probably know that you can just, there's a whole dictionary list that can reference window, right? This, window, document, parent, and the list goes on. And I think I have it further noted later on. But what I wanted to represent here was conditions where and where you could not use encoding. So octal encoding, the hex encoding need to be encapsulated within a string. You can't declare them literally within either a variable declaration or open unencapsulated, because the characters that they use to represent the encoding type causes a syntax error. It in and of itself has significance for other things, like mathematical calculations or regex matches. So octal and hex are limited in this way, but it's also context-driven, right? Because you can use hex encoding if you're going to pass it through a URL first, so you can use it for things like a JavaScript directive, right? So you can do document.location equals, you know, string JavaScript colon, and you can use hex encoding there and clear without any encapsulation. But that, again, it's context dependent. Play with it. It gets pretty easy after a while. So yeah, this is just me, just playing around with different encoding types and how you can bind those to default objects, right? The default object being the alert, right? And I'm binding that to several variables, and then I'm iterating over that several times, and just throwing it all over the place, right? Which is another thing that I think this piece of JavaScript I'll get into later doesn't really do very well. They don't hide what they're trying to do. They kind of assume you're not going to get past the recursion or the unpacking, and so they never really try to obfuscate what default objects they attempt to reference. How are we on time? So, as I stated before, the entire purpose for this first step of the JavaScript was just to check whether or not your user agent header contained the string IE, which is conducted by this second portion. So the first portion was just a giant array, octal encoded. I went into other encoding types you could use. The second portion is a function which references itself wrapped in an evaluation. So it's just this auto-declared function. The function, right now I have it obfuscated as a function contents ellipses. Contained within it, it was just too much text to fit within a slide. But what it does is it has for if or while if loops to replace for or any of the other more accessible looping methods for recursion. And it just uses while if to iterate over first it iterates over some additional content to generate a second hash, and then it takes the two hashes that it has, the one that was already predefined, and then a second one that it generated during the unpacking process, and it uses both of those and concatenates them to create the underlying JavaScript that then executes, all to check whether or not your user agent header has IE in it, which I still think is a crazy amount of work for that. I'm going to use syntax highlighting just to kind of highlight what it's doing. As I said, it's a self-contained. The unpacker is self-contained. It declares the variables off of the hash right after it, which is highlighted now in green. So variable 0xDFFBX1, that correlates to the first entry of the hash. It does some static numeric declarations, and that's again for generating the second hash that it uses. And then it continues on. I'm going to just reference them by numeric value. The variable 4, 0xDFFBX4, that's the second array. That's what gets generated within the unpacker. And then the 0xDFFBX6 is the object literal, which references the prior hash split. Microsoft has plenty of money. All right, so this took way too long to explain, so I just did a visual. It's a lot easier. So you have the eval as the encompassing wrapper. You have the function. You have the two hashes that are passed within the function and defined within the function, kind of cleaned up a little bit. Both of those feed into the final function, the x1, which is what I showed you earlier, the obfuscated single character reference string. That becomes the actual functionality that gets rendered. So both hashes feed into that because they're the representations of all the characters for that, and then all of that gets evaluated. And now they can check whether or not you have fucking IE in your user agent header. That was what all of that was for. And it's kind of, and at this point, with all that effort to get to that, you have to assume that they were using some form of automated obfuscation system. Nobody would manually go through all that effort and then only check for a literal string. So this is programmatically generated, and I have other evidence of other JavaScript samples that function fundamentally similar, with very similar variable declaration styles, that indicate to me that it is programmatically generated, but it uses slightly different obfuscation methods each time. But I don't have enough time to go through every single one of them. Some things they could have done better. There's all sorts of ways you can fingerprint a user agent, well beyond just checking user agent strings, right? There's default variables that get set in all sorts of weird ways, indicating versions based on there's like time delays when you reference default objects that can indicate what version of JavaScript the JavaScript runtime environment is running, which then indicates what browser you're running. So it gets pretty convoluted. They could have used more accurate fingerprinting techniques. Also, I'm kind of disappointed that there was no booby traps. Not even once. After all this obfuscated content, all they did was just reference the user agent header. If you don't have it, then they bounce you to an iframe that takes you to some default Google landing page. But if you do have it, then they point to some statically defined URL, the 91.196.216.20/url.php. When loaded, so you have IE, now what? It utilizes DHTML to iterate over a huge decimal encoded array. Each entry of the array is a unique ID. That unique ID gets appended to a URL, and then DHTML printed out to the DOM so that your browser goes and pulls down each one of these unique payloads. It's essentially a shotgun. If you have IE, I'm going to try everything I know, and hopefully one of those will exploit you. And if it does, sweet, I got a new bot. If it didn't, then it has a meta refresh in 30 milliseconds. So apparently these ODAs work fast. But the meta refresh bounces you to some benign page that actually generates click revenue for them. Clever little RBNs. If they can't get a bot out of you, they'll get a clicks out of you, and they'll make money anyway. Let's see, what else do I have here? So again, going back over some of the things they did and didn't do. They didn't do order of operations type techniques, which I found kind of lame. Order of operations is awesome, because you can use, again, bitwise operators logic, you can use arithmetic, and in doing those in line, forces JavaScript to change the method in which it's interpreting data, resulting in functions that normally would not be evaluated first, would instead be considered part of a string, evaluated prior. So you can nest representations of data in ways that is, on surface value, seems syntactically incorrect unless you understand the concepts of order of operations and included that within your deobfuscator or whatever programmatic analysis engine that you've created, right? So order of operations is very, very useful. Also very useful for things like if you're doing injection into JavaScript space, but you can't use parenthetics or anything to escape out of some larger encapsulation. You just need a string escape, order of operations, and it doesn't matter if everything else is syntactically incorrect after that. It executed your JavaScript first, because, you know, that's awesome. Cross-site scripting is awesome. Some of the other things they didn't do, they didn't take advantage of all the other ways you could define strings. They just do string literal every time. They programmatically generated some unique string, they made that your variable, and then that equals something else. But there's a lot of tricks where you can bind variables that you can define that's outside of the scope of that, that will require additional parameters to whatever analyzer is trying to figure out what you're doing, that's outside of what they would normally check for. So, you know, variables, obviously, that's what they were using, but they could use, you know, regex morphing. There's transition of data types, so that's what the integer type conversion is for. But you can do that from array to string, and you can, you can iterate over all the different, you know, data types. It's very, very useful. And then also evaluation. I mean, they literally said eval. Like, that should have triggered at least half of the AVs. Why is it triggered? Why is it doing eval? But yeah, I mean, and again, you can do this a ton of different ways. These are just some of them, where you can just auto-evaluate content. Order of operations kind of feeds into this, right? Because if you do order of operations within an array declaration, then it evaluates your content before the other. See, these kind of nest together, and you should play with them. I have a whole bunch of, I know I'm talking really fast, and it's because I'm trying to get through a lot of content. There is a whole bunch of reference material at the end of this slide deck, and hopefully that'll be made available to others, and you can, and there's also my email, so if you ever have any questions, you can just, or samples that you want me to check out, I'm always down for that. Um, DOM modification, write append child, 10 minutes. So basic DOM modification type stuff, always very, very useful, but pretty freaking obvious. If they're doing any form of event checking, they're definitely going to catch that, which is why setters are always really, really useful. And then final thoughts. I'm like within my time by like a lot. So I ADD a bit, if that wasn't obvious during this presentation. I have a lot of thoughts going on in my head. What I wanted this presentation originally to be when I made the proposal was to create a JavaScript obfuscation taxonomy. That is a huge project. That is one that I do want to take on. It does require a degree of research. There are already pretty well accepted obfuscation taxonomies, general obfuscation taxonomies that have been published both academically and privately. And I think that it's about time that there be one created for JavaScript obfuscation. The JavaScript standard in and of itself has stabilized to the point where, and a lot of the execution environments have kind of come in line, where creating a taxonomy doesn't seem like too of an impossible feat. And it would also standardize communication across a lot of these groups. There's always the downside that bad guys will also get a better understanding of how JavaScript obfuscation works. But I mean, ultimately, that's not a. I don't consider that a problem, right? We need to raise the bar. Things need to get better, and usually that's motivated through negative reinforcement than positive reinforcement, unfortunately. Other things to check out. I didn't cover EX4 in this presentation at all, and that's primarily because it's a totally different beast, involving all sorts of different data representations, and it's basically the standard that applies to JavaScript within XML space. But all current rendering environments also support that standard within the browser, which means you can reference it within normal DOMs and it just access a totally different execution environment. So cool stuff. I mentioned his name before, but Gareth Hayes is doing a lot of work in EX4. He has a tool called Hackverter that does a lot of automated kind of EX4 transformations, just so you can see some of the easy tricks that he does. But you know, there's still a lot of research to be done there. If you're looking for a place to kind of further the bar for JavaScript obfuscation, EX4 and the UCMA standard 357, that's pretty much what you want to read. So I did a lot of talking. Do you have any questions? Show of hands, how many people have done JavaScript obfuscation before or worked with obfuscated JavaScript? Deobfuscation. How many people have done it as incident response? Yeah. Yeah, I mean, ideally, the information takeaways from this, even though it seems like it's targeted at raising the bar for malicious attackers, really should provide additional information for the defensive side of the house as well, right? You should get an understanding of what obfuscated JavaScript actually looks like and what it could look like. Static string checks don't really work. Honeypots do work, but you have to understand where they can detect or identify a honeypot easily and how to bypass some of those traps, kind of disarm them instantly. Also, I didn't get into it all, but there's a whole bunch of other steps that they can take in the server stack with regards to like limit to one-time access to the IP and other ways that they can trip up analysis or post-exploitation analysis. So it's always good to use things like onion networks or whatever whenever you're interacting with hostile networks, right? After you access it once, if you want to try it again, you might as well just hit the refresh button on your connection. So yeah, that's my contact information. Feel free to cross-site script me on Skype. I'm always down for that. It's awesome, good fun. And then Gmail, of course. That's because everyone apparently has to use it. And then attribution. I do a lot of malware analysis stuff for fun, seeing what the bad guys are doing with a buddy of mine, Curtis Miller. So I want to give him attribution specifically. Again, there's references to all the tools that I made mention of. Sandboxy, which is a sandbox environment for your browser, very useful if you don't want to just get randomly owned with a new O-Day. And again, you have all of that wrapped in virtualization. You pretty much have no risk of ever having any persistent threat on your machine, unless they attack the hypervisor, which is, wow.
So I have a question. I just recently started looking at like JavaScript obfuscation, trying to do research on like exploit toolkits, black hole, and Zeus, and they use
Right.
the obfuscation techniques with JavaScript. Well, looking at like Mozilla and trying to de-obfuscate it, the issue to add is a lot of mutations of the obfuscation. So like every week, the exploit toolkit will have a different mutation.
Right. They'll generate a new.
Right. So
Yeah.
any like this like input where to like look to get more information as far as obfuscation mutation.
The counter mutation.
Right. Exactly. To try to
To determine whether or not they're all from a similar source.
Or to find a way to de-obfuscate the mutation.
Well.
Use Mozilla.
Yeah. I mean, there are some tools out there that, I mean, but ultimately they just become fuller and fuller featured de-obfuscators, right? As it's basically an arms race, right? As they come up with a new interesting rendering behavior, then it takes X amount of lag time to get that introduced into common de-obfuscation engines that are being used, so that you can then see that that's what they're doing. That's where the manual or the human aspect comes into it a lot. It really is a manual problem to solve, unfortunately. I think that, unless you want to take Otis on yourself to improve your own automated de-obfuscator, you're really at the whim of whenever they update the libraries. So you end up having to just do it manually, which isn't that hard. I mean, just, stand up an environment, you play with it. But yeah, if you're doing it across 15, 30, 100, that gets kind of tedious. Ideally, normally in the way that I've seen those systems run in the past, there's other signatures that indicate to you whether or not they're a similar kit, even if it's not the same group that's generating it. Like one of the things I didn't mention that's actually a problem with this JavaScript obfuscation sample is that all of the variables that were being declared not only were a fixed length, but were also relatively low entropy per character, right? Really, really easy to detect that was generated programmatically in and of itself, but then also taking that exact same signature and applying it to multiple obfuscation techniques will give you a pretty good profile that, it's the same kit that's generating it. Not the same person, but at least the same kit. Any other questions? Slackers.org has a ton of people on there. I love slackers.org. You should probably check it out. Gareth Hayes, Kuza55, Sir Darkcat. There's a bunch of guys who have done recent talks on HTML5 and various other obfuscation techniques who participate on there. There's regular competitions for obfuscation competitions and things like that. How to create the smallest executable payload. So I think the Victor was like 6 characters or 7 characters is the least amount of characters you need. And also other tricks like non-alphanumeric. It's not in this version, but there is a method in which you can force default strings to return. So you create a logical statement, right? And it's either true or false or undefined or infinite, right? And that forces, just based on default behavior, the JavaScript rendering environment returns that string to you. So now you have a reference to that string. You have a reference to text created purely out of meta characters, no ASCII at all, or well, no alpha at all, right? Alphanum. And then you can count on that returned string, and you can pull out the letters that you need to build your overall JavaScript payload, concatenate that, and then evaluate it all with like a total of 6 different meta characters, but a relatively long string length to count out each one. It's called default string enumeration. It's pretty cool stuff. Not practical at all. I mean, when you see it, you know exactly what it is, but it's pretty fun if you ever want to just play around with it.
You mentioned HTML5. I just had an interesting idea. I don't know if there's anybody doing research, but it'd be kind of cool to use HTML5 and like web workers and do threaded JavaScript obfuscation. Where you have like parent and child and you have to obfuscate within a thread on JavaScript. That would be really hard to try to do.
Some of the coolest like nested threading or iterations over object trees that I've seen actually came out of what's his name? Zalewski out of Google. His do you remember the name of that thing that he had running? Wasn't Skipfish. He wrote Skipfish, but he wrote something before that was doing a whole bunch of he was just basically trying to find crash conditions in the JavaScript engine, but you can take his exact same JavaScript, the way he dynamically just recursively iterates over entire object model, like generating the object model and then iterating over the object model. you can do that same. He also used web workers for that to kind of implement threading to kind of speed up the process of brute forcing the browser. The only problem with it was that it was all within a single browser environment. So if he found a crash condition, he lost state across all the rest of the ones that were running. So it came pretty difficult to kind of establish a true-false condition for a crash that he wanted to go investigate further. But it's still really great stuff. If you just want to take a look at some advanced uses of web workers, check it out. So I think I'm done. Is there a questions track or no? Cool.
All right.